Hello, GCC geographers. If you've stumbled across this video, this is a feedback lesson from a coast end of unit test that we've done at Pimlico for the Edexcel A specification. For those of you who might have stumbled across it, welcome. If not, hello, year 10s. I hope you find this video helpful. Okay, so we are going to start with a common misconception that that is important to address. So lots of people, and kind of understandably, lots of people get mixed up between the difference between physical processes that happen along coastline and coastal landforms. So physical processes lead to coastal landforms being created. Sorry, my annotation tool is not working. There we go. Maybe I have to keep it open like this. Okay. 1 second. Let's see. I'll move it here. That's nice. Maybe move it down there. Okay. Let's try again. So a physical process is something that leads to a coastal landform being created. Okay. Now, I would like you to pause the video for, let's say, 2 minutes. You can do this in your head, or you can do this on a piece of paper. Throughout the feedback, feel free to take notes, pause it for as long as you need to. That's what it's there for, okay? Little challenge is to try and color code the landforms you identify into either depositional, so that's when sand is dropped by a wave with low energy, or erosional, so that's often caused by high energy destructive waves, an erosional landform, okay? So that would be for this column. Okay, pause the video, have a go. Okay, apologies, I've lost my mouse. Smooth start as usual. Okay, here we go. Right, so we are going to go through each of the answers individually so that you can see exactly where each of the terms fit into this activity, okay? And really try to memorize them as we go through. So a physical process, a kind of term that you often get in a exam question is coastal recession. Now this simply means the coastline eroding. So whenever you hear that word recession, think erosion, okay? Coastal erosion. Great. So next one, deposition, okay? As we said, this is from low energy waves. This leads to sediment being dropped at particular points along the coastline, and that movement of sediment, that transportation and deposition of sediment is the process of longshore drift, okay? Abrasion, I'm just going to write that next to it. Great. Abrasion is a type of erosion. This is when rocks are thrown against the cliff by waves. So rocks almost use as armor, as kind of missiles against the cliff and chip away at the rock on the cliff. Hydraulic action is also a type of erosion. Do we need to write it down? I don't think we do. And then finally, we have longshore drift. So this is where our deposition comes into play. Transportation, the movement of sediment along a coastline, okay? So next one. So landforms, right. So you'll spot that the depositional landform is in red, okay? So see if you got this right. Headland is an erosional landform. These headlands form along discordant coastlines. Discordant coastlines is when different types of rock face the sea. So that would be hard rock and soft rock. And headlands are formed, nice and easy to remember, are formed of hard rock. They're resistant. That's why they stick out into the sea and they're eroded more slowly. Okay, next one. The bar. Okay, so bar, again, we're going to link this to our physical processes. A bar is formed by longshore drift, and essentially is a sort of long stretch of sandy beach that looks sort of different in different places, but it often looks like just a nice long stretch of sandy beach between two headlands. And behind a bar, you get a lagoon, okay? So in the test, you'll see that there is an OS map, and you have to really pay attention to that sort of essentially what the shape of the water is behind, what the water is behind that sandy beach. That sort of is the giveaway. But a bar essentially blocks off that area of water from the sea, and that's called a lagoon. Okay, final one is a cove. Forms along a discordant coastline, a concordant coastline, cove, sea, concordant. And I'm going to do a little video on this separately that will be put up on onto the channel. So do keep going back to watch this. There's a really good geographer online video that you can already watch on concordant coastlines. But I will be doing a little video on this. Now, well done if you spotted that a levee is not a coastal landform. That was a trick question, little trick one for you there, because levees are formed in the lower course of the river, and these are formed on the banks of the river, and this is where large sediment is deposited first because it is heavier, okay? There's a bit of a feedback lesson from the rivers test that you can go back to. Try to revisit this. Okay. So let's clear. Now, igneous rock is, lots of you did remember, but some of you maybe needs a bit of a recap. The igneous rock is formed because of volcanic activity. So either magma or lava cooling to form lovely rocks like granite, anything with crystals in. So you'll see these crystals formed because of the minerals found in the lava, okay? So if you get a question that asks you to explain this, you need to be comfortable explaining that this is formed at a plate boundary, okay? And this is what we call a convergent plate boundary. Plate boundary. Boundary. Tectonic plate boundary. Now, the figure that you got in the exam shows these two tectonic plates coming together and therefore creating volcanic activity. So you need to be confident, literally identifying the fact that was a tectonic plate boundary, but this is where volcanic activity happens, okay? And we've got our lovely volcano here. Right, let's move on. So let's test this. I would like you to pause the video for 2 minutes, just while you read through these statements. And then I will reveal the correct statement at the end of that 2 minutes, okay? Make sure you pause the video to give yourself a chance to identify the correct one. So, correct answer is igneous rock forms the odd one out. Read what I've written on the screen. Come on. Igneous rock forms where river deposition. I can't see my. There we go. Get really smooth with the transitions. I will, of course. Okay. So, igneous rock, the odd one out is igneous rock forms where river deposition has occurred. This is the odd one out because this is how sedimentary rock is formed. So this is the layers of sediment that we find in lowland areas, okay? Areas that have mountains are often where volcanoes used to exist. So they're extinct. Mountains are often extinct volcanoes. This is if it's a certain type of plate boundary. But the odd one out is the odd one out because these three statements are all correct in relation to how igneous rock is formed, okay? So let's move on. I think that's enough of that now. If I can find the mouse, then I will definitely move us on. Give you a chance to read the statements. So igneous rock is lava that has cooled after a volcanic eruption. There we go. Oh no, decided not to. Maybe it's because, apologies, this is a very dull bit, but we will move on in as soon as, there we go, great. Maybe it's something to do with the mouse pad. Right, now, a lot of the questions that you get throughout paper 1 and paper 2 try to trip you up by using more technical language in the question, okay? Technical language that we have covered in lessons, but maybe you haven't spent lots of time thinking about. So when you see these words, you think, oh God, actually, what does that word mean? When if you just broke it down a little bit in your head, then you could then decipher what the question is asking you, okay? A bit like cracking the code. So the first keyword in this question, remember it's an explain 1, so we've got the structure is going to be point, explain, explain, or point, explain, expand on that same point. So you're not making new points or giving new reasons why seasonality affects the rate of coastal recession. You're giving one clear reason and then developing that reason with explain and expand. Okay, so seasonality is when if you didn't know what this word meant, again, break it down a bit like you would in a language lesson, the prefix and the suffix, even in English language or any kind of Latinate language, and even Latin, if you have the joy of doing Latin with Mr. Ferber and Miss Evans at Pimlico. Season means winter, summer, spring, autumn. So you can, I don't know, you can have an educated guess at what that word meant. But if you've never heard that before, seasonality just means seasons. Which season, when, in what season do we see the most coastal recession, okay? So seasonality means differences in weather between these seasons. So in this country, we have 4 seasons. And actually, in many countries that are close to the equator, there might just be a cooler season and a drier season, maybe. But we have very clear, because we're so far away from the equator, very clear differences in weather between winter and the summer, right? Winter, we have lots of rain and storms. The summer, we get very calm, clear weather, most of the time, bit of rain. So, coastal recession, now we've unpicked what that word meant, so we need to think about weather, think about different types of weather during different seasons, okay? That's the hint. So coastal recession, if you remember from the first task, simply means erosion. So in what season do we get the most coastal erosion, okay? Now, I'm not going to give you the answer to this because if you haven't done the test, I know some people will watch this and I want everyone to have a go at it in lockdown. But think about what might weaken the rock during the winter and what kind of specific type of erosion might occur during winter because of the size of the waves and the energy that the waves have, okay? So really, really think about that when you're breaking down the question. So it simply means give one way the winter weather seen in winter affects the amount of rate, just means the speed, like the rate of change. Can't see my mouse again, which is helpful. And yeah, I think that's probably enough said for that. So the speed of coastal recession, the speed of coastal erosion. Great. Let me find the mouse, please. There it is. So now this is a classic bit of exam technique that the more we do it, the better we're going to get at making it into a habit every time you take an exam. Suggest the best thing you can do, a bit like in an explain question, how you in explain you use this means that, okay, as a sentence starter to try and get you to explain the point that you've made. As a good rule, this means that is very useful. Okay, get you to explain your main point. For suggest questions, you need to use this sentence starter, I can see, because it forces you to look at the figure and use the figure. So it says, often the question says, study figure 1. Now, when it says that, it doesn't just mean, oh, have a little look at it and like, oh, lovely, lovely, lovely map, lovely graph. It means actually use a piece of information from that figure and then explain what it shows. Okay, we're going to have a little practice of this, so don't worry if it's still feeling a bit foggy. Okay, I don't want you to write the whole answer for this. I just want you to write down or think in your head what the I can see first sentence would be in this for this question. So suggest one reason why coastal recession is occurring along this coastline. Suggest one reason why coastal recession is occurring along this coastline. Pause for 1 minute and finish that sentence starter, I can see. So select the relevant piece of evidence from that figure. Okay, make sure you pause the video for a significant amount of time. So very clearly on this figure, now this is the Holderness Coast up in Yorkshire, if you're interested. And this boulder clay is incredibly susceptible. So it's very susceptible to erosion. It's less resistant to erosion. Okay. So the sentence I came up with is, I can see that a large area of this coastline is made of boulder clay, which is a sedimentary rock. So you've given that significant piece of evidence, you selected the relevant evidence going to help you answer that suggest question. To then develop that and explain what that means in relation to coastal recession, use the sentence starter, this means that. So a suggest question is similar to an explain question, but you're just simply making the point of your answer the evidence that you can see in the figure. So let's have a go. Let's read through this. Sorry, I think hopefully my drawing tool isn't in the way. Let's see. This means that erosion will occur more quickly because this kind of rock is less resistant. So you've simply explained why the rate of erosion, why coastal recession is happening, because the rock is less resistant. Okay, let's do another one. So this question is about this lovely photo of, this is near Camber Sands, if anyone's been to Butlins, near Rye. It's on the, what's the name of the coastline? That's going to really annoy me. It's a place, very nice place, lots of nice sandy beaches, very nice. So this isn't actually Camber Sands, it's like a little bit further along. Okay, suggest one way human activities have affected this coastline. So pause the video for 1 minute and then I will reveal the correct answer. Okay, I can see that a settlement has been built right next to the coastline. So you're literally identifying that as one whole mark. You're identifying what is the human activity you can see in this photo. Lots of houses is a settlement. So the explanation of this is the 3-mark questions. This is going to be a evidence, explain, expand. evidence being the evidence I can see. So, oh, I don't love it like nice. Click along, please. Thank you. There we go. This means that coastal defences such as a seawall are likely to have been built, so along the coastline, trying to protect these houses possibly. This may lead to visual pollution, reducing the amount of tourists that visit the area. This is a similar reason that you could give for ports. So ports being built along the coastline, industry also creating impermeable surfaces. You could link the explanation to flooding, but you can give this same explanation for ports. Great. So let's move on and have a look at these final two tasks. Got two more tasks for you. So I would like you to pause the video for approximately 5 minutes, and you can do this for longer if you want to really have a kind of good look, cover, right, self-explanation, asking your own questions about these different types of coastal management. So you've got hard engineering and soft engineering, hard engineering being the grey. You will get questions in the exam that simply ask you to explain an advantage and disadvantage of a certain type of coastal defence. You might have to pick that type of coastal defence out from a photo. You might have to identify it on an OS map. So it's really vital that you take time to learn these advantages and disadvantages. You can literally memorise them off by heart. And when we do the field trip, fingers crossed, to Walton on Naze, you'll be able to see some of these types of coastal defence. So you'll probably be able to remember their advantages and disadvantages even more. Okay, so pause for 5 minutes and then let's test our knowledge. Okay, what type of coastal management can you see in this photo? Think about it. Is it hard engineering or soft engineering? Think about the name. Okay, the answer is groins, and this is a type of hard engineering. Even though it's wooden, you can often get rock groins as well that are a bit more hard wearing, but it's hard engineering. The advantages are that it stops longshore drift, and that makes the beach wider because it traps more sediment on the beach. It's easy to repair and maintain. So even though if it was a rock groin, it'd be slightly more expensive, but because it's made out of wood, you can maintain it relatively easily. It might be a little bit expensive if you're paying for that every winter, but it's relatively easy to replace those boards. Okay, think about disadvantages. So disadvantage is that it's unattractive to tourists, stops tourists from walking along the beach, can cause more coastal recession further down the coast. So because it's trapping sediment up here, let's say longshore drift is going south, let's assume this is going south. This means that the beach further south of these groins will have less sediment, so it won't be as wide. That means that the waves will not absorb the beach will not absorb the wave energy. Okay, and that's a real problem for places further down the coast. Okay, think about which one you think this is. Think about the advantages and disadvantages. I'll give you a little bit more pause before the advantages. Okay, this is an offshore reef. Even though it's made of these big old rocks in the image, this is technically soft engineering because it is encouraging a kind of natural process of deposition to happen without interfering with the beach itself. So yes, they have to build it out in offshore in the water, but it is working with natural processes of deposition along the coast. Okay, I've already revealed the advantages, my apologies. So this reduces the power of the waves, so the waves hit hit the offshore reef, and that reduces its energy before it gets to the beach. This helps build up the beach, gets nice and wide, and this is good for tourism, it's good for coastal protection. So the waves, again, absorbing the wave energy, all good all round, basically. Okay. So the disadvantages are that it's hard to install without the calm weather. So you have to have really, really calm conditions to get the equipment out into the sea and to essentially sort of offload all of this rock and sand off in the deeper water. So it takes quite a lot of material to be able to build it. And then it can be damaged quite easily, not easily, depending on what it's made out of, but it can be damaged by storms in the winter, so it's going to cost a bit of money to maintain, okay? Right, this is a reminder that you must be looking at OS maps as much as possible, and this is a little practice for us. Now I want you to pause the video, didn't do a pause sign, sorry. Pause the video for a minute, and I want you to identify the coastal landforms in these maps. Okay, assuming you paused for a minute, let's see if you got the correct answers. So the needles, you can see from this image that there's a very clear headland sticking out into the sea. If you were really clever, you might have spotted these little stacks, and these are called the needles. This is our coastal case study for the Isle of Wight. These are the hard rock chalk needles, and you've got your nice chairlift for the tourists at this point here, the viewing point. Very, very famous stacks. Okay. This again is up at the Holderness coast. Lots of famous landforms up at the Holderness coast. High energy coastline. This is a spit. You can tell because it's curved and it stops in the open water. So this is actually because of the flow of the river in this area. Okay. And then finally, you've actually got multiple erosional landforms in this OS map. You can tell because there's a beach within the bay. So this bay that's cut out, that's eroded backwards because it's made of soft rock. And you have the headland that's sticking out into the sea. Okay. Pause if you need to mark. Great. Okay. So the next task we're going to do, the final task, sorry, I'm not going to model the exam question just in case people are watching this and haven't done the test. I just want it to be as good a reflection of your knowledge as possible. In the exam question for 8 marks, you have to select 4 pieces of evidence to then help you explain how physical processes have led to the formation of this landform. So the landform, and I think in the question it even mentions a spit. The landform you're going to explain the formation of is spit. But you need to make sure that the examiner can see that you've used the figure, because you're examining what is happening in this diagram. Okay. The first thing you need to pay attention to is the compass and the scale. It's often included in this kind of figure. Okay. So think in your head just for 30 seconds and pause the video if you need to. What would be your 4 pieces of evidence identified from this figure that will help you explain the formation of a spit? Okay, the ones I identified were the wind directions. This is the prevailing wind, really important, because what we're going to identify is the movement of sediment along this coastline moving east. So wind direction, prevailing wind from southwest, and the movement of sediment moving east. The next one, the sort of in order of how you would explain it, would be the change in direction of the coastline. So the headland is where it's sticking out, but then the coastline here, let me identify it with a bit of a drawing. The coastline changes direction, but longshore drift continues. So just because the coastline changes direction doesn't mean that deposition isn't going to continue to happen due to longshore drift. Okay. Next piece of evidence is the width of the spit. So I would say this is approximately 15 kilometers. However, in the exam, you need to take your ruler, place your ruler on the scale. It already tells you, actually already tells you that it's 2 centimeters. So you measure the spit, find out how many centimeters it is. If that was 6 centimeters, then you would times 5 by 3, because there are 3 2s in 6, okay? So therefore be 15 kilometers. Okay, then the final piece of evidence that I would use, my fourth piece of evidence, is the river mouth. So the fastest flowing water flowing southeast out of the river mouth means that the spit stops growing towards the next bit of land. Okay, so it stops the spit from developing and becoming any longer. Okay, so have a little think in your head, see if you can remember those 4 pieces of evidence. Pause the video if you want to have a bit more chance to think. Okay, so the 4 pieces of evidence are southwest prevailing wind, longshore drift, moving sediment east and continues where the land changes direction at the headland. That's kind of 2 bits of evidence knocked in together. Reach the headland. So the spit is 15 kilometers long, and the southeast flow of water from the river stops the spit from growing any longer. Okay, I hope you found that helpful. A very nice recording, a slightly different type of video for you guys. And yeah, keep in touch and make sure you have a go at this test if you haven't already.